forgot.
Darn. All right, so today we're going to talk about radians and angles in standard position. Okay, so a radian is just another way to measure an angle. Okay, so we have degrees, right? We always use degrees. We can also use radians. Sometimes those are nicer to use, depending on if you're talking about like circular stuff, because circles have pi in them, and radians are in terms of pi. So we're going to draw angles in standard position, find coterminal angles, and then use the radian measure. So our first box here, in a coordinate plane, an angle can be formed by fixing one ray, which is called the initial side, and rotating the other ray, called the terminal side.
How long is today's lesson, do you think?
Yesterday's video is 40 minutes, so yeah, I know. Hopefully it's a little shorter today. So before we go on though, what's a ray? Remember from geometry? Yeah, what do you think, Ryan?
It's like part of an angle that just like goes out forever and ever.
Yeah. Like it's fixed at one point, right? And then it goes out all the way that way forever and ever. Yeah. Okay, so just like we have there, right, our terminal side, if you look at that in the picture, there's a fixed point at the origin there, and then it's going out forever and ever to like the northwest, I guess. Okay, so terminal side about the vertex, and then an angle is in standard position. When its vertex is at the origin and its initial side lies on the positive x-axis. So that's a lot of really mathy stuff. What are we basically talking about?
Angles.
Angles, yeah. Basically, we can take one side of our angle, like if you think about that as like a clock, right? You can take the hour hand, staple it down on like 3 o'clock, it's not going anywhere. That's the positive x-axis, right? Then you can take that minute hand and spin it anywhere you want it, as long as you keep it fixed at the center. And no matter where you spin it, you're going to get an angle. Okay? That's basically what we're talking about today. Okay? So, let us draw some angles. So we have 240 degrees. If I draw an axis in here, how much is like, if I go from 3 o'clock to 9 o'clock, half of it?
180.
180. Okay, so 240 is obviously more than 180, right? What's 3/4? Anybody know? 270.
Yeah.
Okay, 270 is more than 240, right? But 240 is closer to 270. So I'm going to say, okay, I'm starting here at my positive x-axis, going around, and I'm going to stop here. Drawing my ray, and call that 270 degrees. 240. Whoops. There we go. 240. How many degrees are in a full circle? 360. So 500 is going to be a lot more than that, right? So we have to go all the way around. Okay, what's 500 minus 360?
180, no, 140.
140, okay? So we're not going to quite go another half turn, right? But we're going to be close. So I'm going to come around here, come up here, and draw my ray in. Well, or what?
Just drawing some swirls.
Just drawing some swirls, you know? How about -50? What do you guys think there? It is going to go counterclockwise.
Haven't we been going counterclockwise this whole time? Like swirls.
Or we're going to go clockwise, yeah. I always screw that up too, because like negative you think counter, like, you know, but yeah. Anyway, so yes, we are going to go down here, -50 degrees, draw an array, label it, And there we go. Okay, so what were to happen, let's just say I have an angle that's 310 degrees. What's it going to look like? Is it going to look like one of those three graphs? Yeah, why would it look like negative 50?
It's 360 minus 50 is 310.
Yeah. Okay, so 360 minus 50, I'm going to do this one in green, equals 310. Did you say Earth Day?
It was like Earth Day last week.
Oh, okay, yeah.
Yeah, Earth Green.
So if I start here and I go around the circle this way, I end at the same spot, right? Okay, so that's what a coterminal angle is. So angles are coterminal. When their terminal sides coincide. So when that minute hand that we're moving around, when that coincides, an angle is coterminal. So how many coterminal angles are there for a given angle? Comes in pairs.
That couldn't be infinite because there's a lot of. You
You keep going up.
yeah, you can keep going and going and going. You can stop at the same spot.
Yeah.
What does coincide mean?
Like they like happen in the same spot, basically.
Almost like coincidence.
Yeah, exactly. So what do you guys agree that there's probably an infinite amount of those? Because you could just keep adding 360, adding 360, adding 360, right? And you're going to end up at the same spot. Okay? So let's find some coterminal angles. So we want to find one positive angle and one negative angle that is coterminal. So yesterday's class was kind of mixed up on positive and negative. Positive's a positive number, and negative's a negative number, right? Okay, good deal. We're on the right track there. So, finding coterminal angles. So we have negative 45 degrees. How are we going to go, if we're down here, how are we going to go and find a positive coterminal angle? What do you think we do?
The same angle.
Yeah, we'd go the opposite way, so we'd add 360, right? We want to go all the way around the circle once. So take 360 minus 45, which is the same thing as negative 45 plus 360, right? So 360 minus 45, and what does that equal? 315. So one of our coterminal angles is 315 degrees. How about if we want a more negative one? Would we add 360 again, or would we subtract it? Subtract it. So take negative 45 minus 360. Should get negative 405. Does that sound right? Yep. So there are your two coterminal angles for negative 45. One positive, one negative. And obviously you can do 675. That would be coterminal as well. So you can go around the circle as many times as you want. All right, work with your partner and see what you get for a coterminal for 395. Want one positive, one negative. You have one behind you.
Oh, I do. But that's correct, right?
Close.
But that's not a negative.
Right, make sure that you have one positive, one negative.
Yeah, that's not supposed to be negative. I just kind of.
Oh, yeah, I got you. Yep. No, you're right there. Yep.
Do we need to draw that graph every time?
No, I was just showing you guys. Yeah.
You don't need to have a just wait, do you need to have a negative one?
Yeah, one positive, one negative.
Minus 360 again?
Mm-hmm.
Oh, when you get your homework done last time?
Yeah.
You sure got her done.
All right, so we got 395 degrees. What was the one positive angle that you found?
35.
What was yours?
755.
755. You had 35, right? Anybody have something different besides those two? Yeah, I don't know. Those are two pretty good ones. So we have 35.
Actually, 1,115.
1,115. That is also a good one. Okay. How about a negative one? Negative 35.
325.
Negative 325. I agree with that one. Because negative 35 and 35 wouldn't meet up.
I have a 750.
Negative 755?
No, I had positive 755. How do you get negative?
Oh, yeah, I got you.
360, because it has to be at the same angle.
Yeah. Okay.
It's still gonna be negative 35.
If the angle's right here.
How do you get 1,000?
You just went around the circle an extra time.
You just keep adding 360.
You just keep adding 360. Keep more circles.
Like a track is 400 meters, right? So if you go around the track 3 times, you've gone 1,200 meters. That's kind of the idea
If you go
here.
one more, then 1,600 meters.
And that is
a mile.
a mile.
Wait,
Whoa,
so would
you
negative
know.
35 work?
I don't think negative 35 works because when you subtract 360 from 395, you're going to get positive 35, which would be an angle about like that. So negative 35 would be
Minus 360.
like that.
Negative angle.
What did you? How did
So
you
they wouldn't be
find-
coterminal. What'd you say?
Tripped out, bro.
Oh, me?
Did you say? I didn't hear
Yeah.
you.
What? How'd you find negative 325?
Negative 325.
So we're
Okay.
back with the circle again.
So you go 1 revolution back, and that gives you 35. So then subtract 360 again.
Did you have to use like a negative formula? Or something?
Yeah, the formula for that, technically, Luke, would be 395 minus 2 times 360. Because you went around the circle 2 times. Does that make sense?
Yeah.
Clear as mud.
Clear as mud.
Basically, you subtract it by 360, and if it's negative, that's what you do.
That's
Because we want 1 positive, 1 negative. So if you subtract by
If it's
360.
negative, then you just, the next one you just add it.
Right, exactly.
And if
Yeah.
it's positive, then you subtract 360 again.
Yep.
Oh god.
Yep.
Basically, we're just gonna call it quits today.
Basically, you're adding or subtracting 360 degrees as many times as you need to get to where you're going.
How did you
How did this take 45?
3 which one?
How do you know to go around again?
You can go around as many times as you want, remember?
Yeah, 395.
Because you want one positive and one negative. Just keep it.
Yeah,
Just
move on.
one positive, one negative.
You have to be at the same
Opposites
spot.
attract.
That was a positive number.
Add or minus 360 to be in the same spot. And you
Okay.
need 1 negative angle. So you need
Oh,
to
that looks
add
good,
minus
Luke.
360.
What?
Here,
I'll
I'll
take
like
that.
move on to the back
I'll
side.
take your word.
Later, when I go snack.
This
Luke.
backside is gonna take 16 years.
Alright, we're good.
Like, why we got the wheel of fortune?
Okay,
in the back?
if you're not quite good, we'll talk. So, as Luke said, let's go on to the Wheel of Fortune. But first we got to understand what the Wheel of Fortune's about, okay? So we're going to convert between degrees and radians, okay? Remember I said radians have something to do with pi, right?
Oh.
Okay, so if we want to convert from degrees to radians, we're going to say, okay, I've got degrees. Whoops, that's digress. Whew.
Rossi was a good show.
Okay, so we have degrees. Okay, we want radians. What are we going to have to... Here, before I start, I'm going to tell you pi radians is equal to 180 degrees. Okay? So, if I want to get rid of my degrees, do I need 180 on the bottom or pi on the bottom? I want pi on top, right? Because I want my answer to be in terms of pi, because radians are in terms of pi. So I'm going to multiply this by pi over 180. Okay? Exactly, because then you have degrees in the numerator and degrees in the denominator, and they're going to cancel each other out. You're left with just the radians.
So radians is pi.
Radians is pi. You're always going to have radians in terms of pi.
1 pi, 2 pi. So
What is a radian?
3
again?
pi over 2.
It's high.
A radian is just another form of measuring an angle. It's like centimeters to feet, you know. I guess it would technically be like meters to feet. But it's kind of the same thing. It's just another way of measuring it. Or like Celsius and Fahrenheit. Okay? So if we want to go the other way, is 180 going to be still on the bottom or is it going to be on top?
Top.
Right. Yeah, you're going to multiply by the reciprocal, right? If you have radians, multiply by 180 over pi. Okay, then your radians are going to cancel, and you're left with just degrees, which is what you want.
Can
Okay?
you give this formula on the test?
Pi, what does that say?
On the bottom,
Yeah.
it said pi radians. RAD is the abbreviation for that.
Rad.
Rad pi. Yeah. Okay? Like rad. No.
Yeah.
Yeah. Okay. I don't know if you'll get this on the test. I don't think you'll really need it on the test. So I
Wheel of
wouldn't
Fortune?
bet on it. No, the that stuff. Converting. Yeah. All right. So let's convert some of these. So we have 120 degrees. Are we using the first formula or the second formula? First one. And I lost my pen. Okay, so we're going to times by pi radians over 180 degrees. My degrees are going to cancel. 120 divided by 180. What's that? Huh.
I thought we multiplied it.
2/3.
2/3. We are multiplying. But when you multiply a fraction, right?
Sort of.
Okay. So you got 2/3. And then don't forget your pi up top. So 120 degrees is 2 pi radians over 3.
Is that your answer?
That's your answer.
What's this guy do with the Wheel of Fortune?
We'll get there.
How do you get that?
So
Yes.
when you multiply fractions, right? Technically that's 120 over 1. So you multiply across, you have 120 pi over 180.
Great.
Okay. That's great.
Yeah.
Yeah. All right. Negative pi over 12. First formula, second formula.
Second.
Second. So you're going to have negative pi over 12 times 180 degrees over pi radians. Your pi's are going to cancel. So you're going to have negative 180 divided by 12. Anybody know what that is off the top of their head?
Oh.
Come on, it's 15, guys.
Negative 15.
How come my 180 is negative?
Wait.
So once we cancel that pi, we have like a negative 1 basically, right? Technically what we did here is we multiplied. So we have a negative 180 pi over 12 pi. So then our pi's cancel. And then negative 180 divided by 12. Okay? All right. 3 pi over 2. Figure that one out with your partner.
Gotta cancel the pi.
Got to cancel the pi.
Yes.
I got 270, is that right?
270. What do you guys think? Do you agree with Peyton?
Oh, sorry, Ryan. I agree.
I agree with her as well.
Oh,
3 pi over 2 is kind of a famous, famous isn't the right word, but 3 pi over 2 is a pretty common radian measure because you,
630.
Then you're wrong.
630?
Yeah, you're
Did you,
wrong.
did you,
Wait, Peyton, what do you use?
270.
I don't know.
Oh.
So 270, I agree. Okay, how about the next one?
Huh.
I'm going to guess it's between pi over 3 and pi over 6. See what you get.
I got 0.25.
0.25. What's that as a fraction?
Oh. Gotta change it.
Oh, pi over.
1/4.
1/4, and don't forget your pi, right?
One. Pi over 4.
Pi over 4.
Well, I'm just gonna put 1 pi over 4.
And you can do that.
The same thing.
Yeah, so shut up.
I wasn't grinning.
Z-snap.
Yeah, or two.
All right, so we got pi over 4. So these last two are going to be part of Luke's Wheel of Fortune down here, okay? So
Yeah.
let's look at this.
I think Easton O'Connor Banger scheme should hit it first.
Well, since you volunteered for me, you can do it.
I like that idea.
Come on up, chicken head.
All right.
He's talking about me.
All right, so our degrees are going to be in green, okay? I'm going to fill that in real quick. If
Ryan.
yeah. Yeah.
Let's go. Degrees.
Okay. So what if my terminal side is on the positive x-axis and my initial side? I don't have like any angle, right? So that's 0 degrees. Does that make sense?
Yeah.
Okay. So this is 0. This is going to be 30 degrees. That's going to be 45 degrees.
What's this called?
It's going to be 60 degrees.
It's Wheel of Fortune.
90. What's 90 plus 30?
Gosh, we're so good.
I already said 120.
What is
120.
that- What is that number though after 45?
9,
That
60. Go back.
135.
I need to work on your grade.
That's how you write 6 in Icelandic.
What are we increasing by?
I don't know. I
That's
totally
not
made that
even
up.
real language.
By 15.
You know that's a
I
real
would know
country,
'cause I
right?
take Rosetta Stone.
Oh, okay. So 120 plus 30 is 150. What's halfway around the circle? We talked about that earlier.
Wait.
180. 270. Close. Okay. Plus 30 is
Another
210.
210. Okay. And then 225. Exactly. What's our next one going to be?
260.
240.
240.
240. And then at the bottom here is 270.
300.
300.
330.
And then 330. And then what's all the way around the circle? 360. So what are 0 and 360?
They're the whatever.
Co-terminal.
Coterminal. Exactly.
Oh.
Wow. Fancy.
So what now?
So what now? Now we want to talk about radians. Okay? So
Hi, crackhead.
0 degrees is going to be 0 radians.
0 degrees.
Okay? So we know how to convert, right? So 30 degrees.
Yep.
Are we timesing by pi over 180 or 180 over pi?
Pi's on top.
Pi over 180, pi's on top. Okay? 30 and 180, that gives us 1 over 6. So we're going to have pi over 6 is equal to 30 degrees.
So we just write
Do you pick out random numbers?
So right, pi over 6. No, I did not pick out random numbers. What, you know, like a 30, 60, 90 special right triangle?
Yeah.
Yeah,
No.
that's where this kind of comes from.
We're gonna have to go through all these.
But it's easy, okay? So,
You just add 2 every time, right?
so if you have pi over 6 is 30 degrees. How many 30 degrees are in 60 degrees?
2.
2.
So how many pi over 6s are in 60 degrees?
2.
What's 2 divided by 6? 1 over 3, right? So 60 degrees is pi
Over 3.
over 3.
Oh my.
Woo!
What? This is
We skipped 45.
We'll get back to 45, okay? 45 acts a little differently.
Well, that's not.
Why do you know it's pi over 4?
It's 1/4.
45 by 180.
Yeah. 45 divided by 180, right?
So it's 1/4.
So it's pi over 4.
You just do this stuff in your head.
We'll come back to this, the 45s though. Let's just focus on the 30s. So you have pi over 6, 2 pi over 6. What's 90 degrees going to be?
5 2.
Pi over 2, right? 3 pi over 6. So pi over 2. How about 120?
Pi. It's just pi.
Look back up in your notes when we converted.
2 pi over 3.
2 pi over 3. Okay. If you times both those by 2, you get 4 pi over 6, which makes sense, right? We're going up by pi over 6 each time. So 150, we're at 4 pi over 6. Add another pi over 6, we're at 5 pi over 6, right? So 150 is 5 pi over 6. If you're converting it, you're going to get the same thing. Okay, 180 degrees we said is equal to pi radians, right? And that makes sense because if we add another pi over 6, we have 6 pi over 6, which is just pi.
You should get 35, 135.
We'll get back to it.
We're skipping the
Okay, we're at 6 pi over 6, add another pi over 6. How many pi over 6s do we have?
6,
7.
7. So we have 7 pi over 6. Okay, next one's going to be 8 pi over 6. What does that reduce to?
4/3.
4/3. So 4 pi over 3, exactly.
4 pi over 3.
Okay, 270 we found earlier. We said that was what again? 3
Pi over 2.
3 pi over 2. Okay, so that is, what is that? 9 pi over 6. So add another one, you get,
8 pi over 1.
not quite.
4 pi over 2.
You have,
9 pi.
4 pi over 3.
you have 9 pi over
3 pi.
6.
2
pi
pi
over
over 1.
5 pi over 3.
Yeah, that's a good one. Melissa.
Yeah, what's that?
Okay, how about our last one there? We're going to get,
30.
2 pi.
not quite.
That's 360.
We're gonna-
The,
We're at 10 pi over
6
6.
over
We added one more
2
pi over
pi.
6.
Oh, excuse me, I got
oh,
that.
it's over 6, I know.
So it's going to
11 pi over 6.
be 11 pi over 6.
But 360 is 2 pi.
And then 360 is 2 pi. Exactly.
1 pi squared.
Not pi squared. Okay.
Woo!
All right, so we said 45 degrees is pi over 4.
Yep.
So that's 1 pi over 4. 90 degrees is 2 45s, right? So you got 2 pi over 4, which is pi over 2. What's the next one going to be?
35.
135 is going to be
3 pi over 4.
3 pi over 4. Okay. 180 degrees is going to be 4 pi over 4.
5 pi over 4.
5 pi over 4.
6 pi over 4.
6 pi over 4. And then finally 315 is
No, that is 6.
7 pi over 4. 6 pi over 4 is going to be 270.
Oh.
Yeah. 7 pi over 4 is going to be 315.
Holy hell.
And then 8 pi over 4, you're back to 360, which is 2 pi.
What
Okay.
now?
Okay, so
But
So,
you said, oh, never mind. Never mind, I got it.
so these are really good to have memorized.
We're not
Okay.
gonna
I would.
Is that another one of your famous jokes?
No, no.
Give me 15 years and I'll come back.
Get you 15 years, okay.
Okay.
hold on. Let me try to figure this out.
Nice one, Ethan.
So,
Nice one, Moody.
okay, so this is a little bit of cognitive science here, but your brain only has so much working memory, right? You have short-term memory, you have long-term memory, and you have something called working memory. So you can only really do 5 to 7 tasks at one time before your brain is overloaded and can't do anymore. So if you have this memorized, you can recall it from your long-term memory and it doesn't take up space in your working memory. So some of these get kind of complicated, right? And if you have to constantly be like, okay, I have to go back, I have to check it, okay, now I have to remember that, okay, now I'm trying to do this, you're probably going to lose something in there. So it just helps to have it
These last ones
memorized.
are easy.
These last ones are super
You
easy.
just look at them.
Alright, let's not even do them.
Oh no, we're going to do them.
We should do
What
them
are we
because.
done? What are we doing?
So 135 degrees, what is that in radians?
3 pi over
3 pi over
4.
3 pi over 4. Change negative 40 because that's not on our circle. And what did I have that as? Make that negative 120. So what? Yeah, degrees. So what's that coterminal angle?
240.
240. And what do we say 240 was?
4 pi over 3.
4 pi over 3.
I like the harder way, like the longer way. Like did something.
Yeah.
Why would we just
Alright, I don't know why we did that, but okay.
So 5 pi over 4 is
235.
225.
25, yeah.
Okay, and then finally pi over 6 is
30.
30 degrees.
Let's go.
Okay.
How long was that?
I'm gonna do this.
We are going to